All right, page 2, number 6. We're doing some number theory. Write the following in base 10. Oh, yeah, okay. Remember these? We've got a different base. We like base 10, but we now know a lot about other bases, right? Let me get my calculator for this one. All right, remember how we change from this base to base 10. When we're going from another base to base 10, we, what's the word? Expand. Expand this thing. The base 8 tells me, I'm doing a base 8 to a power, so I take the 7 times base 8, so 8 to a power. Now, let's go ahead and try to figure out the power. What power of 8 would that be? Well, it starts at the back. The 5 is going to be power of 8, what? 0 power. 1 power, 2 power, 3 power. So the 7 is going to be 8 to the 3rd power times. Then the 3 would be times 8 squared. Again, why is it 8? Because that's the base. And then 2 times 8 to the be for the first. And then 5 would be times 8 to the 0. I'll go ahead and write down the power. All right, so 8 to the 3rd. 8 to the 3rd is 512. Yeah, I knew that. 3 then is times 64. And then 2 is times 8. And then what about the 0 power? What's the 0 power of 8? Anything to the 0 power is 1. So we've got 7 times 512 plus 3. I'm going to do that. 7 times 512 plus 3 times 64 plus 2 times 8, 16. 5 times 1 is 5. 3,797? 3,797. That's number 6. I've got our check answers on the back, so make sure I'm getting these right. Yeah, all right. Don't want to tell you wrong here right before the final. All right, number 7. Write the following in base 8. This is a base 10, and I know that because there's no base showing there. So I want to write 695 in base 8. Well, that's going the other direction, so to speak. I'm going from base 10 to another base, and so I do that differently. How do I do that differently? I use what? Successive. Don't say it all at once. Division. Successive divisions. Yeah, I'm going to take the base 8 and successively divide it into 695. So I'll start with the first one. 695 divided by 8 goes 86 times. I just want the whole number part there, but what else do I want? Over here to the side. I want the remainder. Now it's 86.875. The remainder here is not 8. How do I get the remainder? To get the remainder, I've got 86 times 8 is 688. So what's the remainder? Remainder would be 7, right? With me on that? Remember that? No. Okay. Well, now you do. All right, number 2 step is to do the same thing, just divide by 8 again. How many times does 88 go into 86? That's an easy one. 10 times. Goes 10 times, whole number, evenly. But there is a remainder, I should say. 10 times 8 is 80, so what's the remainder? Remainder of 6. You want to put the remainder each time. Can I divide by 8 again? Yep. Can divide by 8 one more time. 8 goes into 10 one time with what remainder? 2. Now I'm done. Remember the number now? We start here and go around like that. 1, 2, 6, 7. Base 8 is the 695 number in base 8. All good? All right. Then we also talked about, well, we talked about some actually it was before this, we talked about Roman numerals, Babylonian numerals, Egyptian. Egyptian is probably the easiest, but let's do some Roman and Babylonian. 694. We're going to first write that in Roman numerals. Well, this is one of the things I do provide is the symbols. You don't have to necessarily remember the symbols. You know, you got your I, your X, your V. I've got those listed, what those are each worth. But in this case, we're going to look at this as what? 694. Because there's some things with the Romans. Now 600 is not too bad. What can I do for 600? I've got a 500 and a 100, right? 500 is D and 100 is C. So for 600 I can do DC. Now 90. On 90 I've got L is 50 and X is 10, but what's wrong with L, X, 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 X? That'd be 90, but the Romans didn't like that because they didn't like more than 3 in a row of the same type. So L, X, X, X is not what we're shooting for. Here we're going to use the subtraction principle. Remember, if we put a smaller one in front of a larger one, we can do subtraction. And in this case, we've got 100 is C, 10 is X. So couldn't I do XC? Wouldn't XC be 90? Because that's 10 from 100. Because the smaller before the larger. Now 4, that's probably a more common one. It's not 4 i's, it's same thing. Subtraction principle, V is 5, I is 1, so IV would be 4. Because you would subtract 1 from 5. Remember that? That's the Romans. Try to recall some of that. All right, now I also wanted us to do a number 8, 694 in Babylonian. Well, the Babylonians were a bit different. They only did wedges. Well, they did wedges and a double wedge. Single wedge is 1. Double wedge, remember, was 10. But if I just do those, that's a whole lot of wedges for 694. Now remember, what they did is they had a base of what? Base 60. Yeah. They had the base 60. So I'm going to divide. I'm going to take the 694 divided by 60. And that's going to give me along about 11.56. So I'm going to take the 11 there. I'm going to do a double wedge and a single wedge for 11. But that only gets me so much of it. That's 11. That's going to be 11 times 60, which is 660. So what do I need in the second group? Well, I need 694, so I need 34 over here, which would be 3 doubles and 4 singles. So I have 2 groups. I have a 60s group and the 1s group. Ring a bell? Vaguely? Okay. Is that all good? All right, number 9A. 9A, we have, show that 127 is a Mersenne Prime. Yeah, there's various things to know on number theory. One of the things I like for you to know is what we mean by Mersenne Prime. What do I mean by Mersenne Prime? Mersenne Prime is a prime that you can write in a certain way. Remember what the way is? It's 2 to a power minus 1. There's a power of 2 minus 1 that gives me 127. So you just have to figure out which power it is. 2 to the 3rd, 2 to the 4th, 2 to the 5th. Remember which one it is? 2 to the 6th is 64. What's 2 to the 7th? 2 to the 7th And then minus 1 isn't 2 to the 7th, 128. And then when you minus 1, you get 127. So there you go. There's proof. 127 is a Mersenne prime. 2 to a power minus 1. All right, B. We want to show, well, we want to find out, is 120 abundant, deficient, or perfect? Let's start with perfect. How is a number perfect? Remember? You sum the proper divisors. Yeah, all the divisors up to that number. And perfect, the proper divisors are equal to the number itself, right? Proper divisors are equal. How does abundant and deficient work? Well, it's abundant if the proper divisors are more, deficient if the proper divisors are less. Okay? Abundant if the proper divisors are more than enough, and deficient is if they're less. So we just need to figure out 120, the factors there of that, which we can use our little technique there. We know 1's a factor, 2 is a factor, 3 is a factor, 4 is, 5 is, it's got a bunch. 6 is, goes evenly. 7, finally we get 1, no. 8, I believe so. 8 is. Yeah. 9, no. 10, yes. Just checking all these just kind of quickly. 11, no. 12. And I think we've reached the halfway point. So, yeah, 10 goes with 12. So 8, I didn't do it. 8 would go with, what was it, like 15? Yeah. 6 would go with 20. 5 would go with 24. And 4 would go with 30. Oh, we got a bunch. 3 would go with 40. 2 would go with 60, and 1 would go with 120, but it doesn't count. So I've got a bunch, and we can kind of see here, if I add all those up, even just the last 3, you got 130, but has anybody got those added up? I think it's on the back here. If you add all those up, I'm saying you get, I don't know. I didn't put it back in the back either. All right, 130, 54, 74, 27, 18, 11, 10. I think it's about 230. So what is it? Proper divisors added to be 230. It's abundant, yeah. 120 would be abundant. Okay. With me on that? All right, number 10 on the handout. We're into counting now. Yeah, and we talked about various ways. We did blanks, we did combinations. 10A, I want committees of 3 from a club. Committees of 3 if the club has 17 members. Well, the thing you ask on these counting, is it a combination, or if it's not a combination, I use the blanks, right? Is this a combination? How is it a combination? It's a combination if order doesn't matter. And on committees, ABC is the same as CBA, isn't it? It's the same committee. This is a combination. Order doesn't matter, so yes, it is a combination. So I would do a combination of 17, 3, right? The number of options, no total number available, how many I want at a time. 17, 3. So 17, then we just use our calculator there to do that. Combination 3, 680. $10B, how many ways can a club elect or select. How many ways, I'll say it right here in a second. How many ways can a club with 20 people elect a president, vice president, and secretary? Well, A, B, C, if I have that president, vice president, secretary, is CBA the same? No, it's not. It's different. CBA is C president. So this is not a combination. Order does matter, so this one's blanks. President, secretary, president, vice president, and secretary. Sorry. Use the blanks. And the deal is, how many can I have a president? 20. I start there. But what about then the vice president? It goes down to 19 because you can't have repetitions. And then 18. 20, 19, 18. That would be 6,840. Do I have a C? I think so. How many 8-card hands have 5 clubs and 3 red cards? 5 clubs and 3 red cards. Okay? All right, so we're doing hands of cards. Are those combinations? Yes, hands of cards are combinations. Order doesn't matter in a hand of cards. However you look at them, they're the same hand. However you arrange them. So these are combinations. Now this one I'm going to do 2 combinations, right? One for the clubs, one for the red. What about the clubs? I want 5 clubs. I need to figure out the combination there. Well, how many do I have to choose from for this part? If they're doing clubs, that's one of the suits. There's 13 of them, right? Ace through king. It's 13 clubs, 5 clubs at a time. What about this one? This one I want red. The hearts and the diamonds are red. So that means how many cards are there for red? 13 hearts, 13 diamonds, 26. I want 3. 26, 3. So combination 13, 5. What do we get there? 1287. 26, 3. 2600. Now that gives me 2 numbers. What do I do with them here? Well, the word is and. And we've studied that several times now. What does and mean? Multiply. And means multiply. So I'm going to multiply 1287 times 2600. 3,346,200. See if I got those right. Okay. All right. All right.